Welcome to the Make course. I'm Rudi Schlaf, a professor at the Department of Electrical Engineering at the University of South Florida. This video shows how to design a feature for mounting a SG90 servo with Autodesk Inventor. So I'm going to discuss here how to use project geometry to get part dimensions of a downloaded model of the servo. And then I'll show how to add a solid body to a part file so we can build this little enclosure here for the servo around it. And then I will also discuss a little bit how to design something like that to when taking printer tolerances into account to make a part like this fit. I downloaded a model of the servo that's in the Arduino kit. You see that here. So that's a pretty nice model. It has most features of this servo. And so if we want to design now a feature that you can mount this servo to, the first thought usually is, how can we start designing this? What is a good surface to start from of this object here? And so I think because we want to design something where we can stick the servo into, the bottom of the servo is a pretty good starting point. And so the first thing we do is to define a work plane. And so I just click down here and then pull it out with the mouse. And we have here inches that I don't like very much. So let's first go into tools and document settings and units, and here we can select millimeters and we apply that and close. And so let's try this again with that plane. And now hopefully see here now we have millimeters. I tend to think in millimeters, and so a pretty good offset here is 0.5 millimeters. Why am I choosing 0.5 millimeters? Because 3D printers tend to vary a little bit in the dimensions what they print, and especially when you make an orifice to stick something into, then this orifice is usually a little bit smaller than how you design it in Inventor or any other CAD software. And so I make 0.5 millimeters gaps around an object when I design something like this here. But this is only a starting point. This may need to be optimized for the particular printer that you are using. But anyway, here now we have this surface, and so we can start a sketch on it. So select sketch and then click on that plane. And so now it turned it here flat to the screen in front of us. That's usually not a very good starting point if you want to project some geometry, because you want to see which corners and edges you want to project. So I turn it like this here, and then I select project geometry and I turn on the construction line feature. So this has the consequence that the lines that I'm generating now on the sketch are not interpreted when extruding features. So these are purely help lines, so to speak, for designing this object now. But here now with project geometry we can select edges of the object, and you see here we get these dotted lines on our sketch. And here we have a little bit X-ray vision, so we can see here this is the edge back here, and then back here there is the edge in the back. And so if we turn this, then we can see it. Oh, this was the wrong direction, so let's just turn this 180, and now here you see very nicely that we have a projection of that bottom surface of the servo. So this is our starting point for the feature that holds the servo that we are to design here. And now I also want a 0.5 millimeter distance around the servo sidewalls, and so a really great feature here is the offset command. And we can just select now this path here, this loop, and pull that out a little bit, and you see here now it shows us the millimeters already as I pull this, but we can also just numerically input 0.5. And so we made a great feature as a construction line, which we don't want. So I'm using the back buttons here to put this away, and so turn this here off, and now we do it again. Offset, select the loop and pull it out and enter the offset that we want. So now you see here we have a rectangle that is just 0.5 millimeters away from the construction line that we projected. So these are the inner boundaries of our enclosure, and now we want to define the outer boundaries. And so since we want to design something here that allows to bolt this servo to with those mounting holes that it has here, we want to go out at least to the end of these mounting tabs. And for that reason I project these two. So project geometry, construction line, and so we select this here. So you see here now down here we know how far to go out with our enclosure, and here we can do exactly the same with this corner. And so now we can turn that conveniently in front of us, so we can now make another rectangle. And of course we should turn off the construction line for this. And so let's just pull a rectangle around here. Oh, it doesn't let me do it here. Okay, so there. And now we need to constrain the dimensions. So here, let's say we just want to go 1 millimeter further out than those tabs. So I put 1 millimeter here, and I can just with the mouse here, I can pull this out and then put a dimension on it. And if we want to have the symmetrical, we can now here simply click on this dimension, which is dimension number D3. And when I code this, OK this here, then you see here it wrote fx. Let me magnify this a little bit. fx1. Fx stands for function, I think. So this here is a function of the other dimension. And so the consequence is, if I change this dimension now, let's say we want to go out 2 millimeters, then it changes it here also. So these two are connected together now by having done what I just did. So let's go back to 1 millimeter. And so now we need to think about how thick do we want to do these side walls on the long sides of the servo enclosure. And if it's just about making a little box to put that servo into, a good dimension for some walls like this here is 2 millimeters. That prints very well. Okay, so let's put here 2 millimeters on this dimension, and down here another 2 millimeters, and so here also I want this symmetrical. So okay, now we have the outer walls defined, and we can click on finish this sketch, and now we need to extrude the walls. And so I click here on extrude, and I select the area that I want to extrude. So that's very easy here because we just have two areas, the outside and the inside. You see when I select it, it turns a little grayish. Okay, so we want to extrude this now up to the tabs of the servo, because that's where we want to put the bolts into that enclosure. And so we change here from distance. Right here now it's selected a 10 millimeter height of this extrusion, but we select now 2. And now we can select a surface up to which we want to extrude. And so of course we want the bottom of these mounting tabs, and so I click on it here, and you see now that this enclosure has been extruded up to the mounting tab. So this is exactly what we want, right? Because we want to bolt it onto this here. Now the final thing we need to consider is that at this point Inventor assumes we want to add this feature to the servo, right? Because we have only one solid body, but of course we want to have it separate so we can print it without the servo in there, because we buy the servo somewhere or we have it in the Arduino kit. And so for this we select here new solid, and now you see it changed the color a little bit, and that indicates that we will now get a second solid body, and you will see that when I click OK. Now we have two bodies, and so body number 1 is the servo and body number 2 is the enclosure that I just designed. So we can call this here actually servo, and solid number 2 is the enclosure. Okay, it's always nice to put names to things, especially when you have like 73 different bodies in your design, and then it's much easier to find them. Okay, so now we have this enclosure, but we still need a close the bottom if we like, and I would do so. I would like to do so. And so for this we can now activate the sketch again. You see here it is now not visible anymore, right? If I select it. So okay, so now here the sketch has vanished because we used it up, so to speak, but we can reactivate it by right-clicking on it and turn on its visibility. And now we see it again, and now we can extrude it again in the other direction. And so we select the outer area, but this time also the inner area because we want to close the bottom. And so a pretty good thickness here for something like that is 1.8. You may wonder why not 2. Well, I like to print in 0.3 millimeter layer thicknesses for objects like this here, where the resolution is not so important on the sidewalls. And if you have 0.3 layer widths, it's good to do all vertical features in multiples of 0.3 to not confuse the printer and to get exact dimensions out of it. And so 1.8 is of course just 6 of these printer layers, 6 times 0.3. Okay, so here now we almost ran into trouble, but I just caught it. You see our bottom plate here is marked with these dotted red lines, but the servo is also marked. So this means Inventor at this point would like to add this bottom plate to the servo, and so we need to change that. So for this we can click on that select the solid button, and we select the enclosure instead. And so now you see the servo turned off and the enclosure is on and the bottom is on. And so when I click OK now, the bottom has been added to the enclosure. And so now we don't need the sketch anymore, so we right click and turn the visibility off, and now we just have the enclosure. Okay, so the next item here is to drill holes into the enclosure so we can use some bolts to fix that servo in its position here. And for this we make another sketch, and this time on the top surface of this enclosure. And now we use project geometry again and turn on the construction lines, and now we select here, turn it off somehow. So I need to select here now these holes that are in the servo enclosure. So here and there, and now you see here the centers of these holes are marked on our sketch. And for drilling holes with the hole tool, it's good to make points there in these locations. And so we make a point here and a point there, and now we have the sketch that we need for using the hole tool. So now it's maybe convenient to turn the servo off so we see things a little bit better. So now we have these 2 points here on our sketch, and when we activate the hole tool, they get selected automatically. So there are 2 selected now, and what we want is a hole that doesn't have a seat. Right, we can also, if we want to countersink a hole, we can actually define here we would want a flathead screw like this here, for example. But since the head of our screw is above the mounting tab of the servo, we don't need a seat for these screws. And so we select just a regular through hole without seat, and we then select a surface down to which we want to drill these holes. And so here now you see that 2 holes are being drilled through the enclosure, and the diameter of 2.5 is just good, because these holes here of the servo enclosures, they are 2 millimeters in diameter, and if you use screws that are self-tapping, like sheet metal screws that cut their own threads into the plastic as you drive them in, then we want to have the hole a little bit smaller than the screw. And when we take into account that 3D printers typically make these holes 1 millimeter in diameter smaller, or 0.8 millimeters or so, 2.5 turns out to be a pretty good starting point here. This doesn't mean this will be perfect. As I said in the beginning, this needs to be printed at some point, and then the dimensions checked, and then this model here needs to be changed appropriately to get a good fit for everything. But at this point, let's be happy now with the 2.5 millimeter hole. And so here we go. So when we turn on the servo again, then you see here that these holes are exactly under the mounting tab holes of the servo. So we are hopeful that this will turn out to be a nicely fitting object. So the final thing is, what's not shown in this model here is that the servo, of course, has wires that come out of it, and they typically come out on this side. And so this is the final thing that I want to do here. We need to make an opening now in this in this side of the enclosure, so we can feed the wires out when we stick the servo in here. So we select this face here, and we start a sketch on it. And now it's convenient again to turn this servo off, so we don't have an obstructed view here. And so now we want to project first the bottom of the enclosure, so we don't drill the hole into the bottom. So we use project geometry again, and we select here that corner inside the enclosure. And so you see here now we get basically where the floor is of the enclosure, and now we can build on that. So let's select this surface. And now it's time to make a rectangle, because the servo has a wire to board header attached to the wires typically, so we need some kind of rectangle where we can feed it through. And I think maybe 3 millimeters should do it. Maybe we should do 3.5 millimeters. And so this here now would be a pretty good hole already for this servo to feed the wires through, but since we print it from the bottom upwards, this is a difficult feature to print, because we have this fairly large horizontal spot here. So what we want to do is to make this top here triangular, so the printer has an easier time to print it. And so I make a triangle on top here. And this triangle now we dimension with a 45-degree angle. My experience is that 45 degrees most printers can handle when it comes to features like this here. If you would make this angle smaller, a lot of printers would have issues with printing this properly, right? Because gravitation pulls the printed plastic downwards, and so you get some bulging and ugly features here. But 45 degrees often works well. So why is this not constrained here properly? It seems to me that somehow this here didn't constrain well to the projected line. So let's do that point constraint and select this here, and see now everything is blue, so it's properly constrained. So there's one more thing I'd like to do before I extrude this. This line here is useless for our extrusion because it's right through the middle, and so I make it a construction line. And so now we have a single loop that is easily extruded. And so now, in comparison to earlier, we make an extrusion that is a cutout. So we switch it here to cut, and again we select that 2 feature, and we select the wall in here, and so that makes sure that this cutout goes all the way through. Okay, now we have this cutout where we can put the wires from the servo through before we stick it into the enclosure. Now you see here I messed up a little bit because this hole here now messes up this nice shape here of my feed through, and this here actually can cause again trouble with printing because we have a hole here that ends up over an empty space. And so I want to change this feature, the whole feature. And here you see a great feature of Inventor and all other CAD software. You can change these features after the fact by simply double clicking and then changing things. So let's assume we just use a shorter screw. So we turn off this extrusion to the all the way through the bottom, and we select distance instead. And so let's say we know that we have 10 millimeter screws, so we could make this here 10 millimeters and click OK, and we still have that hole here, so we need to make it even a little bit shorter. Okay, here, hole a little bit shorter, so let's use maybe an 8 millimeter screw. And now it's gone. So this here might actually print fairly happily. Okay, and now we can turn on the servo again. And so now you see the entire assembly here in its beauty. So typically the wires come out of the servo right here. So you get the idea how to do this. Okay, so we're almost ready to print this part. Now when you print a part and you know that this here is the surface that defines its bottom that starts growing from the printer surface, then it's a really great idea to put a fillet on it, because the first layer always gets a little bit squashed, and if you don't fillet it, then some plastic will stick out here to the sides, and that makes it a little bit ugly. So a 1 millimeter fillet is typically a really great thing to put on the surface that connects with the printer bed. And so here we can select loop and then select this entire loop here, and we say OK. And so now we have this fillet, but when you print this here, then this fillet typically goes away, and this box here, this enclosure, will just be a sharp angle, will have sharp corners at the bottom. But 3D printing is a little bit an inaccurate science when it comes to the practical implementation, and so one critical point is always what happens at the bottom where it grows from the printer surface. Okay, another thing we could do actually, I thought, is, let's turn the servo off again. Typically when you have holes like this here and you want to put a screw in, then it's good when they also have a little bit of a fillet, because also printers sometimes mess it up on the top here, and it tends to be a little bit tighter than further down sometimes. So here we can try a 1 millimeter if we have enough plastic around it. So yeah, it's accepting it, so this is okay, but maybe not pretty. Let's make this 0.5, so we have a little bit of a fillet around these holes. Okay, so let's see how this prints. And in order to print it, what you want to do is, okay, first of course we want to save all this here. I should have saved that earlier already a few times, but I forgot about it. Okay, so it's saved, and now we can go in File here and we click Export, or we just hover over Export, and then we select here CAD format. And now it suggests here DWG as file format, but that's not being used for 3D printers typically. So here we have the STL file, which is the 3D printer standard. And so we export this as an STL file and we say save. Okay, so let me go and print this and I'll report back. So here the printed enclosure. So let me show you what we got there. So the triangle came out very nicely, right? So there is no bulging or hanging out threads or anything. So this worked well, 45 degrees. So now let's put this servo in. The header fits through and we put in the servo. And now you see here that I messed up because I didn't verify that the model that I downloaded actually corresponded to my little servo. So it appears the model that I downloaded is for a slightly bigger servo. So anyway, we need to modify this now, and I will show that in a bit, but let's have a look on top of this here. Let's see if our holes fit. And so you see that here the holes are exactly where we need them. So this part is good, so we don't have to change that. But now let's modify here the height of this enclosure. So let's put the caliper to it and measure the enclosure so we can modify the model accordingly. So here we get about 15 millimeters. So the great thing about these kind of CAD programs is that we can now go back in and exchange the dimensions with what we need. And so the first extrusion that we made, that defined the depth. So the difficulty here is now, of course, that I pulled the extrusion up to the tabs on the servo, so we can change this now to distance, back to distance, and we make this here 15 millimeters. And let's see if that updates. So this has a little problem. So of course everything else gets confused now. So what we need to do is we need to basically help the software here to identify things properly, where for example this sketch is related to. And so when a sketch is has gone bad like this here, one thing you can try is redefine. And so we select now this new surface and we accept. And so it still said it failed because we still have a problem down here, but you see the holes are back where we want them. And let's just now look at this fillet. That of course is also confused because the plane here has changed. So we can double click this and we select the two hole orifices and simply delete this feature and the sketch. And now we can, it's always good to keep the fillets at the end, or often it is good. I shouldn't generalize, but in this case I think it is good. And so we make a new sketch here and we project again the floor of the enclosure. So here we project, and now we have our line again, and we can make the triangle, turn off the construction line. So, and now let's make this here a little bit smaller. I measured the plug width and it is about 9 millimeters. So, and now of course we want to have it centric, so we can, I can show you now how to do a little bit of math with these dimensions. So this here is of course a projection, so we can only have a dependent dimension here, so it's 13.4 millimeters. But now if we want to put this rectangle into the center of that enclosure wall, we can now simply say we can do a formula here, and so that's an interesting thing to do. So the formula is this dimension, oh, I clicked it twice, minus this dimension, right? So now we have basically what's left over here, and we divide that by 2, and so we get here just a dimension that puts this rectangle into the center. So this here, I think we had at 3. I think 3 is good here. And now I want to make that triangle again. Here, catch. And dimension this again to 45 degrees. So here, 45. And oh, I think it somehow, it put a right angle here, I think, automatically. So, and we turn off, I need to go out of the dimension command with the escape button, and so now we can make this a construction line, and we can extrude this again, make a cut, and to the inner wall. I need to rotate this here a little bit. Hang on. So rotate and here. Okay, so now it extrudes that hole through the entire thing. Okay, so now our hole up here is a little bit too long, so we can change the hole. And we make the bolts a little shorter. Let's say 6 millimeters. Okay, so now this is closed again, and so now we can activate our fillets again. So the end of part indicator can be moved around here, which is often very convenient if you want to change things and then work your way back down and update everything like I just did it. Okay, so we have a modified part. Okay, now it's time to export this file again. So we go into export and CAD and save it, and I just replace the old one, and now we can print it again and see how this fits. I'll be back. So here you see the two parts in comparison. This here is the latest revision, so we have the smaller orifice and it's a little bit shorter, a few millimeters shorter. So let's see how this servo fits in here. Here I'm checking the plug, so that goes through. So let's put the servo in. I already put the screws in to the servo, and so now we can see if this bolts to the enclosure. You see the screws go in fairly well. They sit fairly tight, but this will be different for each printer, so you need to play with these hole diameters a little bit until your printer does this right for the bolts that you have. These here are 256 bolts, which are almost 2 millimeters in diameter. Okay, that looks pretty good. So here the wires come out where they should. The servo matches the enclosure. So mission accomplished. Okay, that concludes my video about designing a feature for mounting a servo with Autodesk Inventor. Thanks for watching.